only when you actually want to buy, right? With that mindset, if you go and visit the website, right, not for just browsing, their 60 to 80% of the traffic will reduce on their servers, right? So currently there are, suppose, just I'm giving a hypothetical scenario here, there are 0 to 100 servers, they have kept it, okay? Out of that, only suppose 3 are being used actual for transactional. So if they do only the transactional traffic, only the people who are actually trying to buy, they should be able to manage with, I'm just giving 3, maybe 30, suppose. Only with 30 servers, they will be able to manage. Remaining 70 servers, they kept it running for the window shoppers. Because Amazon doesn't know who is logging to their website for buying things or not buying things. They can't distinguish with what mindset you are going to visit the website, right? So they can't basically make unavailable for you and make available for a person who wants to buy. Okay, though there are a lot of smartness has come in the UI aspect of it. The understanding your click natures, understanding your details, like when you try to read more and more review, you go much deeper in details. Slowly Amazon starts learning that you might be interested in buying, and then they might start treating you differently. You might start getting the premium services internally, which you might not be aware. There are a lot of intelligence goes under it, right? So with mouse click behavior on, there are intelligence these days that on the website, when you open a website, where your mouse is, where your pointers are, what section of that particular website people spend most time in, right? So you can basically render the data in that way, and by understanding your behavior, also they can understand whether you really want to buy. So those, keeping aside those things, what we are trying to point here is that, so these 70 servers are basically for you, for window shoppers, for contributing 0 to the organization. Only 30 servers are being actually being used for transactional. Remaining 70, the maintenance cost, the server cost, everything cost is going in water, right? It's just no use, right? But it is still there just to serve you traffic, just for the browsing traffic, right? So it is pretty expensive. And and on top of it, you have a database, you make a database call. So imagine a scenario. I just now will come to know why cache is needed. So you have hit a URL, it came to your whatever load balancer, it came to your server, it went to the database, it got the item details, return it, render it, and serve to you. You are just hitting unnecessarily, you are checking the phones, this phone, that phone, are checking this dress, that dress, and you said, okay, I'm bored, I'm leaving it, and that's it. You made so many unnecessarily calls. You made DB calls, this. What they want to prevent this from happening, because database resource is pretty expensive. They want to use it only for the transactional database. If you are really interested in buying and you want to do really shopping, then only they will let you hit the database. And how do? They most of the time they serve the data from the nothing but from the cache. They don't send you the real data from the database. Most of the time they send the data from cache. Only when you go to the checkout page, actual transactional page, they get the data from the database. Otherwise, everything is cached. In fact, the entire page is cached. Whatever the page you see on the item page, when you click on, suppose, a phone, all the data has been flattened out in a particular big fat JSON. It could be like, thousands of JSONs all are merged together and put it back into the cache. When you click on that, it will simply get the dump of the entire JSON, render it, and put it in a second, right? So why do they do it? There are two reasons. There are two primary reasons. One, of course, they want to save the database cost. Second is they don't want to call so many API to gather the information. Just imagine when you click on a particular phone that you want to see this phone's data, just remember or recall the details, what you see on that page. You see review details, you see the availability details, when it will be available, you see the product description, video, feedback, below you see a lot of other details, specifications, how to use it, what not to use, all these things you see on the single page. Imagine if you need to hit the databases, there will be more than 20, 30 or 50 or maybe 100 microservices will be kept in action that, hey, get me the pricing, hey, get me the order, hey, get me this, get me the feedback, get me the overall rating, get me this review, get me these videos, right? So many things will be there. And will you really think that you will be able to make so many calls, so many merging of the data, and then providing that in real time? That is a daunting task. And that also for what? Just for a window shopper, right? So just imagine these kind of scenario, how to tackle it. How can you tackle it better way? So the way you do is you basically whenever a new product gets launched, during the setup process itself, you compute everything. Make a JSON, make a flat JSON, make a flat XML, make a flat protobuf, make a flat of data, whatever you do, you push it as flat as possible into the different caches. And when something comes with the product ID, with the machine ID, with the phone ID, whatever you want, you just get that, dump into the UI. Whenever there is a change happens, now the question is how to happen change. Whenever the change happens, again you recompute everything in the backend, because the product description changes and all these things are in e-commerce is a little rare, because it will not change that much, right? So in those cases, you can basically, what you do is that you again trigger update, you again make a flat and just remove the older one, dump it with the new one.